Okay, so if you have clicked play on this, I'm going to assume that you have done the worksheet that looks like this that's in our Canvas class, and you have answers to the questions, and you're trying to see if those answers are correct. I would like to confirm with you whether or not those answers are correct in this time. So here we have a part of our integral whose derivative is pretty much hiding out right here, and that's a dead giveaway that we should probably use a U-substitution. The derivative of x to the fourth is well known, and so now we want to replace this, but we don't quite have that. Oh wait, now we do. Compensate. So now the 4x cubed dx, 4x cubed dx gets replaced by du. E to the x to the fourth, well, x to the fourth gets replaced with u, and it's an integral, and there's a 1/4 that's there because we had to compensate from this 4. When x is 0, what's u? When x is 1, what's u? And as before, this integral has the same answer that this integral does. So to answer this question, we answer this one instead because it's easier. Fundamental theorem of calculus says find an antiderivative, sub, and subtract. Sub, subtract. And guess what that is? Hope that worked for you. Same sort of thing's going to happen here. There's a part of our integral whose derivative happens to be hiding there. So the thing whose derivative happens to be hiding there is probably a good u. du is 2x plus 2 dx. We're trying to replace this. It's kind of hard unless there's a look at that. But you can't just throw a 2 in there without compensating. So now everybody gets replaced. 2x plus 2 dx, that's here, gets replaced with a du, which means there's nothing left in the numerator anymore. The denominator is x squared plus 2x, that gets replaced. There's a 1/2 from before. Now from where to where? When x is 1, what's u? And when x is 2, what's u? This integral has the same value that this integral does, and so to do this, we do that because it's easier. What's the antiderivative of 1 over u? Boy, I hope you remember that. Sub, and subtract, and it looks like that. All of these are starting to look the same, right? Like you're probably already thinking, I know what's going to happen. I know what's going to happen. I can't replace this. Oh, look, I can. Compensate. So now we've got 1/2 of an integral of the 2x dx is here. There's no more 2x up there. X squared plus 1 is just, well, I'll tell you what, how about that? And so all we do is find an antiderivative of 1 over u, substitute, and subtract. Substitute, and subtract. Now, I've got to leave it to you to decide why this is that. You've got to think about that. Gosh, I hope you do. Gosh, I hope you do. Still looking at what to do for things like this. So here it's pretty clear what we're going to do. The derivative of this thing sort of looks like that thing. Trying to replace a 3x squared dx. Fine, fine. Need a little extra. Compensate. Now the 3x squared dx is du. It means there's no more numerator there. E to the x cubed, I know what x cubed is, and it's an integral, and there's no limits to replace. So how do we do this? Well, we remember that 1 over e to the u is just e to the negative u. This is not calculus, this is algebra. Now it's time for calculus. The antiderivative of e to the negative u is negative e to the negative u plus a constant. And that means that our answer is hanging out here. But I'm going to leave it up to you to decide why that's true. You have seen this in a previous video. You have not seen this in a previous video, but I'm going to do this somewhat mysteriously and say if you need extra on that, office hours are open. Suffice it to say, there's a U, there's a DU, and so this automatically tips us off that it's either B or E, and we probably have to do something with those limits, so it's probably not that. So I hope that this lets us know that we are either on a good track or not on a good track. Your Calc 2 instructor is going to assume you know a lot about U-Substitution. So if you don't, you should check in with your instructor or someone who can help you.